Examples on limit. Example number 1, using definition of limit, prove that limit x tends to 2 x square plus x divided by x minus 5 is equal to minus 2. Now we can say that limit x tends to a, f of x is equal to L if for every epsilon greater than 0 there exists a delta greater than 0 such that f of x minus L is less than epsilon whenever 0 less than mod of x minus a less than delta. Now in the given example, f of x is equal to x square plus x divided by x minus 5, L is equal to minus 2, a is equal to 2, and let epsilon greater than 0 be any real number. We want to determine the circle neighborhood around 2 x minus a is what, 2. Okay, so consider satisfying the condition f of x minus L is less than epsilon. So consider f of x minus L, which is equal to x square plus x divided by x minus 5 minus L. So minus minus become plus, plus 2. If we simplify this expression, then we get it is equal to x square plus x, multiply this x minus 5 to here, so it is twice x minus 10 divided by x minus 5 is equal to, now this x plus twice x is equal to x square plus thrice x minus 10 divided by x minus 5. The numerator is quadratic equation in x, and we want to determine a two number whose product is minus 10 and addition is equal to thrice x. So this is equal to x plus 5 x minus 2 divided by x minus 5. So this is equal to mod of as we know that mod of ab is equal to mod of a into mod of b, and b is not equal to 0, then mod of a divided by b equal to mod of a divided by mod of b. So here we can write this as x plus 5 mod of x minus 2 divided by mod of x minus 5. So now as we know that this is less than or equal to mod of x plus 5 mod of x minus 2. Since this is a positive, this number x minus 5 is greater than or equal to 0, mod of x minus 5 greater than or equal to 0, and therefore this is less than or equal to x plus 5 into x minus 2. Now say this equation number 1. From this we get f of x minus L is equal to, say this equation number 1. We obtain term x minus 2, but there is one extra term x plus 5. So to remove this term, we consider a unit neighborhood around 2. Okay, so this implies consider mod of x minus 2 less than 1. This implies minus 1 less than x minus 2 less than 1. As mod of x is less than a, then the solution is minus a less than x less than a. So this implies if we add 2 on both sides, we get 1 less than x less than 3 from this. Okay, as we want x plus 5 term, so if we add 5 on both sides, we get 6 less than x plus 5 less than 8, and from this we get mod of x plus 5 mod of x plus 5 is less than 8. So the equation 1 becomes, what is equation 1? In equation number 1 we put the value of this term is less than 8. So equation 1 becomes f of x minus L is equal to is less than or equal to mod of x plus 5 mod of x minus 2, and which is less than 8 into mod of x minus 2 using this property. Okay, so now it is less than epsilon. Now if this term less than epsilon, then obviously f of x minus l is also less than epsilon. So now if 8 times mod of x minus 2 less than epsilon implies mod of x minus 2 less than epsilon by 8. Now here we obtain two condition on x in the neighborhood of 2, that is first is epsilon by 8, and here for to reduce x plus 5 we take the unit neighborhood around 2. So if we select choose delta is equal to minimum of 1 and epsilon by 8 for this delta greater than 0, if 0 less than mod of x minus 2 less than delta, then f of x square plus x divided by x minus 5 minus of minus 2 is less than epsilon for any epsilon greater than 0, and therefore limit x tends to 2 to x square plus x divided by x minus 5 is equal to minus 2. Okay, hence the proof of this example. Now next example number 2. Evaluate the limit x tends to 0 e raised to 1 by x divided by 1 plus e raised to 1 by x. Now first consider right hand limit, RHL, right hand limit. So limit x tends to 0 plus of f of x, say this is f of x, which is equal to limit x tends to 0 and x greater than 0 of e raised to 1 by x divided by 1 plus e raised to 1 by x. Now as x is greater than 0 and x approaching to 0, then 1 by x tends to infinity. So if we take e raised to 1 by x outside from the numerator and denominator, we get limit x tends to 0, x greater than 0 of e raised to 1 by x divided by e raised to 1 by x, 1 divided by e raised to 1 by x plus 1. So what happened here, this e raised to 1 by x get cancelled, and it is equal to limit x tends to 0, 1 divided by e raised to 1 by x plus 1. As x tends to 0, this term, since x is positive, x is greater than 0, so this term tends to infinity. So e raised to infinity is infinity, 1 by infinity is 0, so this is 1 divided by 0 plus 1 is equal to 1. So the right hand limit, therefore or in other words equal to or limit x tends to 0 plus of f of x is equal to 1. Now consider left hand limit. Limit x tends to 0 minus of f of x. This implies limit x tends to 0 but x is less than 0 of e raised to 1 by x divided by 1 plus e raised to 1 by x. Now as x is less than 0, this 1 by x tends to minus infinity. So this is equal to e raised to minus infinity divided by 1 plus e raised to minus infinity. As we know that e raised to minus infinity is equal to 0. So this is equal to 0 divided by 1 plus 0 is equal to 0, and therefore limit x tends to 0 plus of f of x is not equal to limit x tends to 0 minus of f of x. The left hand limit is 0 and right hand limit is what? 1, and therefore limit x tends to 0. From this, since we can say that limit x tends to 0 e raised to 1 by x divided by 1 plus e raised to 1 by x does not exist. This limit is what does not exist. Example number 3. Find the left hand limit. Find a left hand limit and a right hand limit for limit x tends to 1, limit x tends to 1 of x minus 1 divided by mod of x minus 1. So now first right hand limit. Now limit x tends to 1 plus of x minus 1 divided by mod of x minus 1, say right hand limit. Now here this implies x tends to 1 but x is greater than 1. What is the x tends to 1 plus? Means x is greater than 1. This implies x minus 1 is greater than 0, and this implies mod of x minus 1 is equal to x minus 1, and therefore for this limit is equal to, this is equal to limit x tends to 1 but x is greater than 1 of x minus 1 divided by mod of x minus 1. As x is greater than 1, this implies it is equal to limit x tends to 1 of x minus 1 divided by x minus 1. This x minus 1 get cancelled here, and limit is equal to what? 1. Now if we consider the left hand limit, limit x tends to 1 minus of x minus 1 divided by mod of x minus 1. Now here x tends to 1 minus implies x tends to 1 but x is what? Less than 1. This implies x minus 1 is less than 0, and therefore x mod of x minus 1 is equal to minus times x minus 1, and therefore the left hand limit is equal to limit x tends to 1 minus of x minus 1 divided by mod of x minus 1 is equal to limit x tends to 1, x is less than 1, x minus 1 divided by minus of x minus 1, it is equal to minus 1. So again you can see here the left hand limit is minus 1 and right hand limit is equal to what? 1. Right hand limit is 1 and left hand limit is minus 1. Now next example number 4. Find limit x tends to 0 under root of 1 plus twice x minus under root of 1 plus thrice x divided by x plus twice x square. Now if we multiply opposite sign of 1 plus twice x, and x is greater than 0, here x is what? Greater than 0, minus under root of 1 plus thrice x into 1 under root of 1 plus twice x plus under root of 1 plus thrice x divided by under root of 1 plus twice x plus under root of 1 plus thrice x. Then this is equal to, if we multiply and divide by here, divided by x plus twice x square. So this is a minus b, and a plus b is equal to a square minus b square. So this is limit x tends to 0, 1 plus twice x minus 1 plus thrice x divided by x. If we take x outside, it is 1 plus twice x under root of 1 plus twice x plus under root of 1 plus thrice x. So this is equal to, now this 1 plus 1 minus 1 will get cancelled here. Twice x minus thrice x is equal to x. So this is limit x tends to 0, minus x divided by x 1 plus twice x under root of 1 plus twice x plus under root of 1 plus thrice x, bracket completed. So this x will get cancelled here, as limit x tends to 0, this is equal to minus 1 divided by 1 plus 0 inside the bracket 1 plus 0 plus 1 plus 0. So here it is equal to 1 plus 1, it is 2, and times 1 is 2, so it is equal to minus 1 by 2.